All right, I'm super excited for our next speaker, Guillaume Ponsen, Chief Technology Officer at Alchemy, who will be covering why financial apps need a different infrastructure. Please welcome Guillaume.
Thank you. Cool, excited to be here. Hi, everyone. OK, let's talk about RPC and the business of providing infrastructure to financial services. I'll cover a brief history of the space and give you a sense of what has shifted in the last 3-4 years from the early days of RPC to now the requirements of FinServe. Brief history of our business, Alchemy. If you look back about 10 years ago, everybody was providing a basic service for nodes. Essentially, once you wanted to build an app on blockchain, you would typically run a node yourself. The next step up from that, maybe call it 2-3 years ago, was people like Alchemy, like Infura, providing load balancing, scaling primitives, reliability on top of that. That's maybe what I would call the traditional RPC. And that powered MetaMask, that powered OpenSea, many of the big names in the space. And then fast forward from that a few years, we entered the crazy explosion of creativity. Many chains, chains specifically for some use cases, chains that became very big very quickly, like Solana and Tron, that call it the multi-chain era. Mega increasing complexity and creativity. Then we entered the phase of scale, institutional scale. And now we have financial services company, we have the Robinhoods, the JP Morgans, the Fidelity, the Visas, coming to us with much higher requirements. They're not just looking for the app to work, they're looking for the app to scale and to be reliable with the same expectation as an AWS or a GCP. And so I want to give you a sense of what is the difference between 4 years ago, what the Alchemy business looked like, versus what Alchemy business looks like now, and the difference in what we've built in the meantime. So what is difficult about providing RPC? There is a number of issues, and I'll go through them one by one, but relatively quickly. One of them is, hey, you're running your infrastructure in the US. Great. Now, your US users are very happy about that, but your users in Asia Pacific may not love the extra 200 milliseconds of latency. So now, hey, how do we speed this up? Problem number 2 is the load balancing on top of nodes and the basic primitives that Alchemy, Infura, and others provided early on give you a sense of consistency. Like if you see a block, you will not ever go backward in time. But you will start to see corner cases. As you scale, as you get to millions of requests per hour or millions of requests, millions of users per day, you start to see the corner cases where, hey, that breaks, actually. Once you transition from an RPC to a WebSocket call, maybe it becomes difficult. If you fail over from one region to another, then you have maybe a little drop there. So these inconsistencies are a little jarring once you get to big scale. You start noticing them. Issue number 3 is that at small scale, you can achieve reasonable throughput. At some point, you enter the space where you actually need to provide hundreds of thousands of transactions per second. It's a whole different level of scale. One node cannot provide that. Even a small collection of nodes cannot provide that. How do you actually achieve this throughput? It's the third issue we had to solve. Fourth issue we had to solve is you can start with a node, but then as soon as this node goes offline for whatever reasons, the machine dies, then you're in trouble. Now you can say, oh, I'm going to use many nodes, but they're all in one region. If this region loses connectivity to network, now you have a problem. To achieve truly high reliability, like not 3 nines, but 4 nines of reliability, meaning you go from an hour downtime per month to 5 minutes of downtime per month. To achieve that level of reliability, you now need to have many redundancy at many layers. You need to do defense in depth and really be able to recover from pretty much any failure. Problem number 5, traditional RPC as great as it is, and it has powered of the many years of crypto, the APIs are not really suitable for large-scale blockchains. As an example, the typical call you will make to scan the blockchain, the get logs call, is typically limited to 1,000 or 10,000 blocks at a time. If you want to scan the whole blockchain, you have to make hundreds and hundreds of calls just to do one scan. It's incredibly inefficient. And finally, the sixth problem we've had to solve is, as the number of chains exploded, the complexity exploded. Every chain is a little bit different. Like, you can solve the problems for one chain, and the problems will be similar for the next chain, but it will be slightly different enough that, oh, now you need to understand dozens of chains. Like, you need to interact with hundreds of teams on a day-to-day basis to be able to handle the complexity. So those are all the problems we had to solve 3-4 years ago. And I'll give you a sense of how we went about them. But to motivate that, just to leave you with 3 numbers. What are people actually looking for here? Like, we now are serving financial services companies, the banks, the JP Morgans, the Robinhoods, the Polymarkets. What are they actually looking for? They're looking for way over 100,000 transactions per second, so very high throughput. They're looking for 4 nines uptime, meaning less than 5 minutes of downtime per month. And they're looking for incredibly low latency everywhere in the world. Essentially, what they want is fast, reliable apps at scale. It's very simple. They're looking for us to provide the same level of service that AWS provides. So how do you go about that? That's the question we had to solve. And I'll give you a sense of like a few things we did to paint, like give you the intuition a little bit. So the first thing you will run into is, OK, I have my data center in the US. That's the dot over there. This is AWS US East 1, everybody's favorite data center. That's the workhorse of the internet. That makes US East users very happy. The APAC users are very sad because it's 200, 300 milliseconds of extra latency. Simple thing you can do is you go to multi-region. You now have 4 deployments of equivalent size in 4 regions in the world. That covers pretty much everywhere. So now if you're in Singapore, you have good latency. If you're in Japan, maybe you have slightly less good latency, but good enough. So you can do that. But once you know how to do that, then you can go crazy. You can put data centers everywhere. You can put data centers right next to somebody's trading app. And this matters in particular for financial services companies who care about trading velocity, as an example, or even the DEX aggregators in traditional Web3. You can now deploy right next to the customer deployment data centers. The other thing you buy by doing this is that you're not so reliant on one region. So if one region goes down, you're still alive. Your system still serves traffic. You can fail over pretty seamlessly. You have a little bit of a hit on latency, but as a whole, your system does not go down. So that's maybe the biggest unlock. You go multi-region, and you push that to the maximum extent you can push it. Thing number 2 is latency is actually more difficult than that. The multi-region gives you proximity geographically, but to me, latency is a game of details. It's tuning the machines, tuning every single binary, tuning every layer of the stack, adding caches in the right places. Once you do that across the entire stack, you can go from something like 100 milliseconds down to 20 milliseconds. You've knocked down every single problem that is in the way of from the end user to your application. And in particular, like one thing we did, once we've knocked down, like it's a whack-a-mole game. Once you knock down most of them, the last thing we did was we realized, oh, Cloudflare is actually adding a ton of latency. Like when you operate on the internet, typically you take Cloudflare for granted, but truly, no, they add a ton of latency. Once we realized that, we just built our version of Cloudflare and knocked down another 7x of latency at the very end. So if latency is a game of details, like precision and details, block perfect consistency is a game of perfection. There is a lot of places, a lot of failure modes where you're going to go backward in the blockchain if you don't pay attention. Like once a user goes from this API to that API, or from this region of the world to that region of the world, or maybe you have an outage here and the failover causes a block to be slightly out of sync. This is incredibly difficult to get right, but this is the level of expectation that our customers, like the financial services customers, really have from us. The last one, and maybe my favorite, is throughput. When we talk about throughput, essentially it's somebody will come to you and say, hey, I'm expecting my app to have so many transactions per second. And you say, yes, I can do that. But what they mean really is that even if your system has issues, you still have to support that. And then, oh, by the way, they will have a giant spike because it's polymarket and it's election night. You have to support the giant spike, even though it's much, much higher than the regular traffic. So what they expect is throughput when it counts to them. Like during whatever their Super Bowl is, you have to be there for them at potentially a much, much higher throughput than they asked you for. To solve this is partially just, you could have many, many more machines than you need, but that's incredibly inefficient. Like you're running at 5% utilization, you don't want to do that, it's too expensive. So instead of that, what you would normally do, like the way you solve this in distributed system, you make your machines elastic. You allow scale up and scale down very quickly. Traditionally, that has been very difficult with blockchain nodes because they need a huge amount of state locally on the machines. So this was maybe the hardest technical problem to solve, is how do you actually do this efficiently at scale? But you have to be able to support the throughput. So all this to say, once you solve some of these issues, and many more like this, you can see the difference between where we were maybe 3-4 years ago, what I call here traditional RPC, and where we are now and where a JP Morgan expects us to be. It's much higher requirements on reliability, much higher requirements on latency, this idea of having perfection in the block consistency, and this idea that we can now elastically scale and provide much, much higher throughput without breaking the bank. The other bonus and very fun activity is you actually need to become compliant. SOC 2 compliance, ISO, DORA, name it. There's 5 or 6 of those. That is a requirement for the big banks and the JP Morgans of the world. The Fidelities, the Visas, all of them require SOC 2 and above. SOC 2 is just the start. If you take a step back, they're actually good ideas, good practices in general, but they do add a lot of complexity to your operations. So we did all that in the last 3-4 years, and I'm sure our colleagues in the world of RPC have done similar things. The beauty of it is once you get there, we call our blockchain engine Cortex. Like it's trained on many, many years of traffic patterns. We've essentially put all the intelligence we had and a number of AI-oriented modules into that foundation. The foundation is now capable of doing scalable, reliable RPC. Now you can build upon that. You can build more advanced APIs. You can integrate partners in a way where they benefit from all the advances you've made. You can build tooling on top. You can then run agents on top. So all of the rest essentially benefits from that base layer being incredibly good and efficient and reliable and scalable. I wanted to touch upon what I mean by advanced APIs. And again, it's just to give an intuition of what builders actually want that traditional RPC does not provide. But it makes a huge difference if you're a developer. Once you have these primitives, your job is much, much easier. So examples of that is, hey, you want a data index over a chain. Great, you can get that. Can you get the same index across all chains, across 100 chains? Can you do queries across chains? Can you do a get logs request across the entire blockchain, not just segment by segment? Can you sponsor gas so that your users do not have to worry about provisioning ETH or provisioning whatever the native token of the chain is? Can you build a new blockchain that is tuned to the specific use case of the user? All of these and more are APIs or primitives that you can build upon the base layer, and that make a huge difference. And I'm going to show you kind of use cases where we've used a lot of these. I'm actually excited about the right side here. I think the next 2 years, is all going to be about agents. One big effort we have ongoing and a series of launches that we started last week is going to be to make Alchemy usable by agents without a human in the loop. You can sign up for Alchemy, you can pay for Alchemy, all of this purely as an agent, not as a human. You don't need a human in the loop to be able to do the entire thing end to end. I think that's actually for us as an infra provider, it's going to unlock much bigger growth. So let me walk you through maybe 3 examples of all of this, everything I talked about in practice with specific users. The first one I will cite is WorldCoin. You might be familiar with them. They scan your iris, and then that's what they use to give you an identity on the blockchain. They are actually pretty impressive app, not super well used in the US, but it's a Venmo-like app. A lot of developing markets use it. It also has a marketplace of many, many apps in the space of crypto that mirrors of the NFT, DeFi, lending, all the primitives that you're used to on the blockchain. But it's very easy to use on your phone. For them in particular, they really cared about the scaling. And so there was a moment in time where they said, hey, we can't scale anymore on public blockchain. And the big unlock we did for them was, OK, let's build a blockchain for you, tuned to the WorldCoin use case. So it's a custom L2, it's a rollup. One cool thing we were able to do that they really, really cared about is they wanted the sequencer to have a module that prioritizes human transactions over bot transactions. And so if you own your blockchain, this is the kind of things you can do. And so we provide the traditional Alchemy developer platform, but in addition to that, we've customized that blockchain to be priority human, and bots are stacked behind the human transactions. So it's both an interest of scale and an interest of customization. Second example I would give you is we worked pretty hard with JP Morgan to power their USD deposit token. It's a really cool idea. It lets you essentially turn your deposit into a crypto balance on chain. It's kind of an alternative to stablecoin in some ways. I think the main unlock for that particular use case was it's really inconvenient for the users of that product to have to get out of stablecoins, buy some ETH to be able to perform the transaction. So this is a perfect example of where gas sponsorship makes a huge difference. Now, if you're using this product, you're essentially operating all the way in dollars, but you're performing transactions on the blockchain through the gas being sponsored by JP Morgan and us under the hood. Last one, my favorite. Polymarket, hopefully everyone's favorite. Polymarket is a really cool app, like one of the, to me, like really cool innovation that blockchain really makes much, much better. One thing we've done with Polymarket, they wanted to achieve much higher throughput, but in particular during spikes. So you can imagine the debates before the presidential election from 2024, the presidential election itself, then subsequently the Super Bowl, like all of these events, if Polymarket traffic looks more like this baseline, you end up with a 10x spike during that event for an elongated period of time. We spend a huge amount of time with them optimizing for that throughput, and this is where having seen traffic patterns for the last 7, 8 years really pays off. Like we can anticipate what these spikes will look like and how they impact every layer of the stack, and then tune our systems to adapt to the spike. I'll leave you with maybe a couple of thoughts here. So these are just 3 top of mind use cases. I'm really excited about the coming few years. I think these 3 use cases essentially prove that we've made it. We've graduated into the point where we can support large-scale financial services like companies. And so the Robinhoods, the JP Morgans, the Fidelities, the Visas, the Revoluts, like all of these, I expect will come on chain very soon if they haven't done that step already. And I believe we are ready. Like we've built all the primitives they need. We're able to support them. And I'm really excited to build with all of you and the new world of crypto.